So the first concept we come to is the square root principle. And here's the idea of it. If you have x squared is equal to 4, what's the solution there? Well, the obvious solution is x equals 2, but the other solution is x equals negative 2. And so because of this, we have this thing called the square root principle. You can write this down. But the basic idea of this principle is this idea. When you take the square root of both sides to solve this equation, you must put plus or minus on one side. So don't forget that. It's really easy to forget. I always put it on the side opposite of the variable. So I say x, because the square root of x squared is x, equals plus or minus 2. And that's my solution. That's an easy way to say there's two solutions there when you use the plus or minus. And so just designate one side whenever it's an even root, so like square root or fourth root or sixth root. You always have to do that when you're solving. You can take the square root of the whole side. You can't take the square root of each individual term, but the whole side. That means if there's two terms on one side, like 5 squared equals 3 squared plus 4 squared, that's a true statement. If I take the square root of both sides, it just comes into play at some point. I can do that, but I have to take the whole side. I cannot say square root of 3 squared plus square root of 4 squared. It's the whole side together. So just be careful on that. If you take the square root of both sides, do the whole side, not each individual term. Okay, so when you have problems like this, as you can see, this one's pretty easy. Take the square root of both sides. Oh yeah, don't forget plus or minus on one side, so x equals plus or minus 3. Here, before I take the square root of both sides, I want to kind of move this over to the other side. So I get x to the fourth equals 16. Now I'm going to take the square root of both sides. Don't forget plus or minus on one side. You get x squared equals plus or minus 4. And to keep solving there, actually, you know what you can do there would be easier to do. Let's just go ahead and take the fourth root of each side there. That should solve it all in one step. And don't forget, put plus or minus on one side. So we get x equals plus or minus. And if you don't know the fourth root of 16 by heart, the prime factorization of 16 is 2 to the fourth. So if you take the fourth root of 2 to the fourth, you're left with just 2. So the answer would be plus or minus 2 in that problem. Just slightly different variations of the same thing here. So here we can take the square root of the whole side. Take the square root of the whole side, plus or minus on one side. Don't forget that. You get x minus 7 equals plus or minus square root of 3. And we're not quite done here. We need to solve for x. So we add 7 to both sides. When I add 7 to the other side, you could put plus or minus square root of 3 plus 7. But if you want to look like a mathematician, you'll put this one first in front of the plus or minus. It just looks better and makes more sense. That represents two answers, just so you know. That represents the answer 7 plus square root of 3, and that represents the answer 7 minus square root of 3. Now, I'm fine with you just writing it like this. This is a perfectly acceptable answer there. In fact, that's the way I would write it. But you could realize that's really two different answers. Here we have, take the cube root of both sides. So we're going to take the cube root of this side, cube root of this side, and I get x equals 2. No, was I supposed to do plus or minus there? No. Why would you not do plus or minus there? Well, because this is odd. When that's odd, you do not do plus or minus. Now, it's only when it's even you're going to have a plus or minus there. So the idea we've already kind of mentioned, which is you want to kind of isolate the variable with the exponent here. So let's subtract 1 first. You get 2x squared equals 8. Divide by 2, you get x squared equals 4. And now you're going to take the square root of both sides after you've isolated that variable. Oh yeah, don't forget plus or minus on one side. You get x equals plus or minus 2. Okay, so here we're going to isolate the x to the 2/3, so we've got to move the 10 over. We've got to divide by 4 as well, so we'll have to do 4x to the 2/3 equals 100. Divided by 4 would be x to the 2/3 equals, 25? So now we're going to deal with this fractional exponent. Well, to deal with the fractional exponent, we really will have to do something kind of creative here. Remember, we can put both sides to, like we could square both sides, we could take the square root of both sides. We've done that before. Well, there's really two operations we're trying to get rid of on the x side here. We're squaring x, but we need to do the opposite, which would be take the square root of both sides. That will get rid of the squaring of x, and then we're taking the cube root of x. Well, the opposite of doing that would be putting it to the third power, so I'm putting both sides to the third power. Essentially, I'm doing the reciprocal power here, and what happens on the left is we get those, if you multiply reciprocals, you get 1, so on the left we just have x. It's beautiful. On the right we have something interesting here happens, and so we have we take the square root of 5, and then we're square root of 25, and then we're cubing that result. So the square root of 25 is 5, and then we're cubing that result, so we get x equals 125. So that was two steps there. We actually took the square root of both sides, and then we cubed that result. Now be careful about this. Because we took the square root of both sides, this step right here, and this is just a really kind of advanced feature about this particular problem. What do we have to do every time we take the square root of both sides? Well, when you take the square root of both sides of an equation, you always have to remember to put plus or minus on one side. So when you take the square root of both sides, like which you did here, you must put plus or minus, which basically means this ends up being plus or minus 125. So that's the part that students sometimes will miss on this kind of problem. Be careful, if this is an even root on both sides, you have to account for that. This is called, these are literal equations. We're going to solve for a variable. So in this case, we're going to solve for r. So we're going to divide by pi here. Try to get r all along. We get a divided by pi, the area divided by pi, equals r squared. Well, to solve this for r, we have to do one more step. We have to take the square root of both sides. Now, when you take the square root of both sides, what do you have to remember to do? Plus or minus on one side. I want this to be r, so I'm going to put plus or minus here. So, because the square root of this is just r, so I get r equals, and then the other side is plus or minus the square root of a divided by the area divided by the pi, divided by pi. And so it's okay that this side is messy looking. That's what your answer is. So you're not looking to put this into a certain form. You're just trying to solve for whatever variable they tell you to. So here's some good examples here. Some good practice problems. And this is always a tough section here. Solving for h here. So you can do this a couple steps at a time if you want to. I'm going to do this in a couple steps. So that you see this 1/3 right there. Well, how do I get rid of 1/3? You would multiply everything by 3. Multiply by 3. If you do that, what happens is you get 3v equals the 1/3 and the 3 cancel. You get s squared times h. To solve for h, one more step, divide by s squared, divide by s squared, and you got your answer. H is equal to 3v over s squared. Here we're going to solve for h. And again, it's just going to be a couple steps here. This first step is really important that you see. We have something plus something where we want to solve for this variable. The first thing you need to do is get this guy out of there. V minus s squared equals 1/2 s times h. Now you can solve this all in one step, or I might prefer to get rid of the 1/2 first. So multiply by 2, multiply by 2, cancels over here. You get SH equals 2 times V minus S squared. You could distribute that if you'd like to. Then divide by S, and that cancels and you get your answer. H equals 2 V minus S squared over S. Let's keep going, 2 more. And so I want to solve for R. Well, this is just one easy step here because I've got R times that amount. Well, the opposite of multiplying would be to divide. So I'm going to divide by A plus B, divide by A plus B. And that goes away, and you get R equals AB over A plus B. Now this problem is the hardest, a little harder one than we've had before. So here's the problem with this one. I really have a couple of different B terms. I have a B term there and there. So somehow I have to get those on the same side of the equation. I'm going to go ahead and distribute this R and see what happens. R times A plus R times B, some times there, equals A times B. Well, I want both of these B terms on the same side. I want this one on the other side. By the way, there's a plus sign here, not a times sign. There's a plus. I just distributed to both terms. So I'd like to get the AB term over here and the RA term over to the right, maybe. So I have RB minus AB equals negative RA. So I had to subtract RA to move it over. I had to subtract AB, and I get that. And here's the key. If you look at this in parentheses, you might see it a little easier. There's a common factor there that I can take out. The common factor is B. So if I take out a B, I get B times R, big R, minus A equals negative RA. One more step, it looks very similar to this problem we have over there. At this point, we divide by R minus A. Those cancel, you get B equals. Don't try to simplify that. It really doesn't simplify here. Just write it out, negative R over A over R minus A. And you have your answer. That's the lesson. Now do your homework in class. By the way, you may notice that I posted answers to your homework online on IQ. So if you look for the word problems that we had, I have some of those answers posted online. So here were the answers, I think, for the word problems. So you can just get them from the screencast here. So if you're looking for answers that you actually have the work worked out for the homework you did last night, there they are.